Assalamualaikum warahmatullahi wabarakatuh. My name is Taqiuddin bin Ahmad Moin. So this is the introduction for our project. We chose the Iron Man logo as our design inspiration because it embodies the same ideal of quality, innovation, and creativity that both Katia and Iron Man hold. We also wanted to push ourselves to use Katia's sophisticated skill to develop a part that is both aesthetically beautiful and functionally effective. The process of designing Iron Man begins with a thorough analysis of his visual components. We pinpoint the essential elements that characterize the superhero persona, such as the sharp lines, strong posture, and distinctive mask through painstaking investigation and study. After that, these components are converted into a digital 3D model using CATIA, making use of the parametric modeling feature of the program to ensure adaptability and flexibility in the design. Next is the objective. The first objective is to convert the design model precisely and accurately into real prototype. Second, improve the machine prototype surface, polish, and overall part quality. Third is to ensure a productive and error-free production process. And the last is to attain the required surface finish in accordance with design specification, assess and choose the best cutting tool and machining parameters. Methodology. So this is the process flow when we run the whole project. First is we create the model from SolidWorks modeling. Number two is part verification. Number three, technical drawing. Number four, we transfer the model to CATIA V5. Number five, we did the CAM preparation in CATIA V5. Number six, we go through to process machining. Number seven, tool path verification. Number eight, we transfer the coding to Sinotrain. Number nine, we transfer to CNC milling machine, and the last is we did the machining and checking the quality control.
Assalamualaikum. My name is Muhammad Haq'emi bin Muhammad Noor. My number matrix is B0921101616. Okay, here I will tell you about our process on the advanced machining. We choose process facing, roughing, pocketing, profile contouring, isoparametric, and last is drill deep hole. First, we use facing because we want to have the flat surface in our we call object means stock. Okay, and then we choose process roughing because we want to remove large material to make the process faster. And then we choose profile contouring to remove the flat or irregular surface, create slot and hole. Then we choose pocketing, removing all the material close boundary down to deep for pocketing. And then we use for isometric, which is we can cut face strip and align with their isoparametric. And then for the lastly, we use for drill deep hole because we want to make a hole in our product. Thank you. And lastly, you can see here our product for the last simulation. Thank you.
Assalamualaikum. My name is Fairuz bin Jasmin. In this slide, I will talk about result and discussion. Dimension accuracy refer to how close the measure or machine result is to the true or target value. Tolerance refer to the acceptable deviation from the target value. In CNC machining, these terms are important for ensuring the quality and functionality of the machine part. Different machining process have different level of accuracy and tolerance. For the result, as we can see that stock Iron Man reactor have some tolerance for top view. First, we can see 2.25 mm, 74.23 mm, 70.85 mm in drawing, and after machining we get 0.02 mm, 0.03 mm, and 0.04 tolerance for this part. But this tolerance can still be acceptable for stock Iron Man reactor. For side view, another part still have some tolerance. We can see at drawing in before and after drawing result for side view. I can conclude that for this slide, The acceptable tolerance in CAM advanced machining depends on several factors, such as the part design, the material properties, the machining parameter, the machine tools, and the quality standard. Generally, the tighter the tolerance, the higher the cost and the longer the cycle time. Therefore, it is recommended to use the minimum tolerance necessary for the part function properly and to avoid over-specifying the tolerance for non-critical features. One way to determine the acceptable tolerance in CAM advanced machining is to use tolerance-based machining, which is features of some CAM software such as SolidWorks, CAM. Tolerance-based machining use the dimension and tolerance applied directly in the 3D model to generate the optimal tool part and cutting parameter. This way, the CAM software can automatically adjust the tolerance level for each machining operation based on the part geometry and the machine capabilities.
Assalamualaikum warahmatullahi wabarakatuh. My name is Moin Haikal. Today I want to talk about the cutting tools that we use in the machining operation. So for the first one is T5 face mill D63. So we use this is for facing, since merely facing operation to even out the raw material and even surface to expedite the process. So for the roughing process, we use two cutting tools. It is T4 end mill D12 and T8 end mill D8. So we employ 12 and 8 mm diameters since some surface and location call for 12 mm and some just for 8 mm. After that, for the pocketing process, we use T9 end mill D3. Utilize the T9 end mill D3 because its smaller diameter tips make it more accurate and smoother, and it is a great fit for the surface and the hole in it. So for next process is we use T2 ball end mill D6 R3. It is used for this operation isoparametric. It is because it has a rounder tip and it's smoother. With additional programs, this tool will gradually trim the surface of the reactor to make it look more beautiful. For the profile contouring, we employed two cutting tools. It is T9 end mill D3 and T10 end mill D6. The reason for this is that certain sections require the employment of smaller point in order to prevent violation and on small surface, and also we use end mill D6 in order to provide profile contouring on larger surface in a speedier manner. And the last one is the drilling process. We use two cutting tools, T11 drill D3 and T13 drill D10. This is because certain holes have a diameter of 10 and some holes require the use of a 3 diameter point. This is due to a fact that drilling requires an exact diameter because it cuts vertically and consecutively. Okay, next is about surface finish. The workpiece surface differs slightly from the drawing because we program a second operation in CATIA to create a pocketing and facing on the lower surface. However, because of the upper surface that has been machined has a different exit system and cannot be climbed, we refrain from using the second programs during machining.
In conclusion, I have shown you how I use CATIA, a powerful computer-aided manufacturing software, to produce a replica of Iron Man ARC reactor. I have explained how CATIA simplified the production workflow by modeling the manufacturing process, optimizing the toolpath, and produce efficient G-code. I have also demonstrated how CATIA improved the accuracy and precision of the CNC machining process at every stage, resulting in a high quality and realistic replica. Furthermore, I have highlighted how CATIA shortens the production time and decrease the material waste, which are both financial and ecological benefit of using cutting-edge CAM technology. Finally, I have discussed how this project has implication for future manufacturing project, as it shows how data-driven CAM can enhance the capabilities of CNC machining and set new standard for the industry. Thank you.